Now this is slightly different than table 2 because table 2 was always in terms of area to the left. Well, when we use Z alpha notation, we are looking at areas to the right. So if we were to have an example, let's say it was find Z 0.03. What that's saying is they want us to find a z-score that has an area of 0.03 to the right of it. So I generally sketch a picture first, and what I have to think about, an area of 0.03 to the right, that's not a big area, so I know I'm going to be over here, and my 0.03 is the area to the right. Well, now table 2 is dealing with my areas under the normal curve, but it's always in terms of areas to the left. So what I have to do is I have to convert this into an area to the left. So if I have 0.03 to the right, that means I have 0.97 to the left. So I've got an area of 0.97. Well, what I need to do now is I need to go to my table 2, and I need to start searching through the numbers on the inside here, the area numbers. And I need to search until I get to a number that's close to 0.97. Now, knowing that my value is up here and that it's above the mean, that tells me my z-score is going to be a positive number. So you want to go to the half of the chart that has the positive z-scores on it, and you want to look for the number that's as close as you can get to 0.97. Now, when you do that, it turns out to be 1.88 is the z-score, because that has an area, if you track that over, of 0.9699, and then the z-score of 1.89 has an area of 0.9706, so the 1.88 is actually closer to 0.97. So what we have found now is our z-score. So our z-score is 1.88. And that's what this notation is asking for. It wants the z-score that has an area of 0.03 to the right. So you have to transfer it into an area to the left, look for it on the inside part of your chart, and then track that back to figure out the z-score that corresponds to that particular spot. Okay, now when you are working with normally distributed variables, here's kind of our general guidelines. The first thing, it's always a good idea to just sketch your normal curve, so that way you can get a general idea of what you're talking about. So here would be my normal curve, and let's say I'm looking at a z-score of -1, so that would be over here, and that could be my picture for step 1. Then it says part 2, shade the area of interest and mark its x values. Well, now depending on what the question asks, it might want to know what's the percent that lie below this, so then I would be shading the area to the left here. It might want to know what's the percent that lies above this, so I might shade to the right. It might want to know, well, what percent lies between two particular values, so then I would shade in between. And then we can mark the x values. Now if they give it to us in terms of z-scores, you can mark the z-scores. If they give it to us in terms of original data, you can go ahead and put the original data values down here, and then you can do z-scores below them after you find the corresponding z-scores. Then, once you find the z-scores, you have to use table 2 to find your particular area. And always remember that table 2 is in terms of area to the left. Now we have a rule that's way more specific than our 3 standard deviation rule, and it tells us a lot more information. What it is it's the 68, 95, 99 rule. The decimals are actually more exact, but it tells us that on a standard normal curve, on any normal curve, we have 68% of our data is going to lie within 1 standard deviation of our mean. 68% of them are going to be within 1 standard deviation. It then tells us that if we go out to 2 standard deviations, now remember this is above or below, we are going to get 95% of our data within 2 standard deviations. if we go out to 3 standard deviations above or 3 standard deviations below, so within our 3 standard deviations, we are going to have 99% of our data values. And it's similar to our 3 standard deviation rule, which says that most of our values will be within 3 standard deviations, but now it tells us the approximate percentage. 68.26% should lie within 1%, 95.44 should lie within 2 standard deviations, and 99.74 should lie within 3 standard deviations. Now, sometimes we need to find an observed value for a specific percentage. So what you would do would be sketch the normal curve. So they might tell us they want to know between what values is the middle 70%. So what I would do, I would sketch the normal curve, and since it wants the middle 70%, that is a symmetric, so 70% is right down the middle. And what you have to think about is, well, what's left over? Now, if I have 70% in the middle, that means I have 30% left over, but that 30% will be equally distributed above and below. So I would actually have 15% above and 15% below. And then we can shade the region of interest. Well, we're interested in this 70%. Now, when we go to find a particular score, we're going to end up finding a z-score first and then having to use the z-score formula to transfer it back into an x value. When we go to table 2, what you have to realize is that if you're trying to find this first z-score, the area you would need to look up would be 0.15. So you would go through your table 2, scan it until you find that area of 0.15, and when you do that, it is going to be negative 1.04. And then you would use your z-score formula to transfer that back into an actual x value. So you would plug in the negative 1.04 for your z-score, leave x as x, and then plug in your mean and plug in your standard deviation, and you could solve it for that x value. What you could do next then is the same type of thing. You can go find the z-score up here, and you would look up the area to the left, which would be 0.85, or what you will find is that if you're doing the middle percentage, these two numbers will be symmetrical of each other. So since the z-score down here was negative 1.04, the z-score up here will be positive 1.04. That's only if you're doing a problem where it wants the middle x%. So you use table 2 to find your z-scores, and then use your z-score formula to find the particular x value that you need. Okay, the last thing that we have to look at is, what do we do if we have a data set and they don't tell us that it's normal? Well, what we would do is we would use what's called a normal probability plot, and we get that from table 3. So back in your appendix again, you need to go find table 3. And the normal probability plot, once we create our normal probability plot, we look at the general shape of it, and if it's roughly linear, then the data is more than likely normal. Now, this isn't the best scientific and mathematical tool because it says just roughly linear. There isn't any specifications we're going to look at to decide if it's linear or not, so it's based off of your judgment, which means it's up for interpretation. So what I have here is just a data set, and we have to decide if the data set is roughly normal. Well, what we're going to do is we're going to first make a table of values, my x values versus the normal values. And our normal values come from table 3. When you're doing this, you have got to put your x values in order. So from smallest to biggest, they have got to be in order for this to work. Okay, the next thing I need to know is how many values I have. And I have 8 values in this particular data set. Now, if you go back to table 3, it's broken down into several different sections, and that's just because it space-wise. And what we have with 8 values is we have an n equals 8. So you need to go onto your table, and across the top you need to find the 8. When you do that, you will see the numbers in the column below that are negative 1.43, negative 0.85, negative 0.47, negative 0.15, and then 0.15, 0.47, 0.85, and 1.43. So those are the values that you will put next to your x values in your table of values. Once you get that done, you have to plot those values. It's best to do this on graph paper or a graphing calculator, that way it's more accurate. But you'll need to plot those values, and then you'll need to assess whether or not it's normal. Once you get all your data points plotted, you have to decide whether or not it's linear. Now, you can't look at it as individual points, you have to look at it as an overall general shape. And overall, as a general shape, I would interpret this to be fairly linear. I mean, it follows a fairly straight line. Obviously, there's going to be some deviation of the individual points, but in general, I would say this is linear. So then I would say that this is normal. Now, if you end up with a graph that maybe, when you do the points, looks something like that, well, that wouldn't be linear because there's such a sharp curve to it. So your interpretation is entirely up to you, but look at it as an overall general shape when you're assessing normality.